This video is to discuss how to create solutions of a specific molarity, starting either from solid or from more concentrated solutions. So let's imagine we had a question where we were asked to make 100 milliliters of 0.25 molar lithium phosphate, starting from lithium phosphate in the solid form. All right. So to do this, what we need to do is start with the molarity equation. Molarity equals moles of solute over liters of solvent, liters of solution. And we're going to find how many moles of lithium phosphate would be required to make this amount of this concentration of solution. And then we're going to change that from moles to grams. So we know the molarity that we want to be 0.25 molar. We don't know how many moles we need, so we're going to call that X. We know we need 100 milliliters, but the molarity equation requires us to use liters, so we're going to divide that by 1,000. All right, so that's going to be 0.100 liters of solution. All right. The easiest way to do this is to think about cross multiplying, or if you prefer, you're getting rid of this denominator. Either way you prefer to think about it. All right, so that disappears, and now we have X is equal to 0.025, and that's now going to be moles. All right, so that means we need 0.025 moles of the lithium phosphate, but we want to know how we would actually make this, right? So what we have to do then is to change the moles to grams, because we don't have a way to measure moles in the lab directly, but we can measure grams. So that many moles of lithium phosphate. For every 1 mole of lithium phosphate, now we just need to calculate the molar mass of lithium phosphate. Lithium is 6.94, excuse me. We have 3 of those. Phosphorus is 30.97, and then 4 oxygens at 16 each. Gives us 115.79 grams of lithium phosphate. Right? So now we're going to multiply that across. And so we're going to need to weigh out 2.9 using correct number of significant digits, because we only have 2 going way back here to the molarity. We're going to measure out 2.9 grams of lithium phosphate. All right, so we're going to place that many grams of lithium phosphate in a 100 milliliter volumetric flask. And then here's the thing you have to remember. We're not going to add 100 milliliters of water. We're going to fill to the line on the volumetric flask with deionized water. All right? So we're going to fill up to that line, and remember that the flasks have this kind of large bell shape on the bottom, and then they have this really skinny neck. We're going to fill up to that line to give us a total volume of 100 milliliters for the entire solution. All right, so that's how you would make the solution starting from solid lithium phosphate. However, what if we wanted to make the same solution, but starting from something more concentrated? So how would you make 100 milliliters of 0.25 molar lithium phosphate if you were starting from, let's say, 2.25 molar lithium phosphate solution? All right, so how would we do that? Now we're going to employ the dilution equation, which some textbooks refer to this differently than I do. I like to call it C1V1 equals C2V2, C standing for concentration. A lot of textbooks will call this M1V1, M2V2. I dislike that because it implies that it only works for molarity. It doesn't. It works for any 2 concentrations or any concentration unit you want to use. You can use micrograms per deciliter if you want, or some other weird unit. As long as the units are the same on both sides, it doesn't matter. All right. This is mainly just a trick of making sure that we assign our variables correctly. I actually like to underline my values in the question and assign them there. So I need to make 100 milliliters, I'm going to call that V1, of meaning these two are related to each other. You want 100 milliliters of this concentration, so we're going to call that C1, all right? And we're going to start from this concentration, which I'm going to call C2. So what we need to know now is what's our V2? What is the volume of the solution of the 2.25 molar lithium phosphate that we need to measure out? All right, so now we're going to plug these into our dilution equation. So our C1 is 0.25 molar. Our V1 is 100 milliliters. There's no need here to change to liters because whatever unit we plug in for V1, that's going to be the unit for V2. So that's going to be equal to our C2 value now is this 2.25, the concentrated solution. And we're looking for V2. That's our unknown. So we're going to now divide both sides by 2.25. And you'll see here the molarities, you have a molarity in the numerator and the denominator, so those cancel out. That leaves you with a unit of milliliters. So again, that just proves we didn't need to change that to liters. If you'd prefer to have it in liters, it's fine. It's just a little more awkward to me. So we're going to do 0.25 times 100 divided by 2.25. V2 here comes out to be 11. Again, we've only got two significant digits here in this molarity. So 11, and the unit here is going to be milliliters. All right. So now, how would we actually make this solution in the lab? We would measure 11 milliliters of the concentrated, the 2.25 molar lithium phosphate solution. We would place that in a 100 milliliter volumetric flask. And then we would do what we always do, which is we would fill that 100 milliliter volumetric flask to the line with deionized water. All right. So again, let's contrast what we did here. In the first question, we were asked to make a solution starting from solid lithium phosphate. All right. And we had to use the molarity equation to get moles and then change moles to grams. You place that many grams in your flask. You run the DI water up till it to the line, all right? In the second one, we're doing something similar, except we're going to use a concentrated solution. So we've got to use the dilution equation here. We're going to use our dilution equation to calculate how many milliliters of that concentrated solution we're going to use. Then we're going to dispense that 11 milliliters into our 100 milliliter volumetric flask and then fill the line with water. All right. So it looks like it's the same problem, but you have to be careful because if you're starting with solutions, you need to use the the dilution equation. If you're using solids, you're going to use the molarity equation and change moles to grams.